Okay, so for the example, okay, we have done example 3. So from this example 3, the limit and the order of integration are not given, but you can just refer to the information provided, so then you can determine the order and also the limit. Okay, now the next example we have also the order is not given, but the limit also not given, but the region are already given in the interval form. So in this case, you don't need to sketch the region. So because we have an idea directly from the information provided, the limit of y is from 0 to 1 and the limit of x 0 to pi over 2, and they are all constant, so meaning that we have a rectangular region. Okay, so to solve this, and you have to, okay, firstly we have the double integral of the function x cos of xy, and it is better for you to put the bracket and dA. Okay, and the region are based on the value of x from 0 to pi over 2, and then y is from 0 to 1. Okay, so now we have to determine which order of integration that we want to use here. Since we know that dA can be dx dy or dy dx, which means that if you choose dx dy, so you have to integrate first with respect to x. If you choose this one dy dx, so you have to first integrate with respect to y. Okay, so in this case, okay, I'll just refer to the given answer here. So let's say we start with the dy dx. Okay, so we choose dy dx, so we integrate first with respect to y. Okay, but then I didn't want to start with dy dx, but I want to start with the dx dy. So you have to integrate with respect to x first. Okay, so since we want to choose this order, so then you have x cos of xy dx dy. Then we just substitute the limit for this particular x and y as given. So x 0 to pi over 2, and then y is from 0 to 1. Okay, so even though the instruction there is no bracket, but for you, because you do the handwriting, right, it is better for you to put the bracket. Otherwise, I'm afraid that after a few steps, you just lost and you just write down to be that one, which means that you have the multiplication of x and cos x and y. Okay, so to be safe, just put the bracket. Okay, so you're not wasting your mark. Okay, so now back to the question here. So you have to solve this in the integral first, which means that okay, just look at just integrate the x cos xy with respect to x. Okay, since you can see you want to integrate with respect to x, so the x that you have is outside the cos and inside the cos, which means that you cannot just use maybe substitution works. Okay. Okay, before we proceed with the to integrate this particular integrand, just to have a quick revision on the integration method. So you have to implement all the integration method that you have learned before this, where the integration method that we can have is, we call that as a substitution, by parts, or maybe you need to simplify your integrand using trigonometric identities, and then also you cannot directly integrate, but you can reproduce, rewrite that function into some particular function, and from there you can integrate, or you can have the partial fraction. Okay, so in this case, if you look at this example, so you want to integrate respect to x, so you can see x inside and you can see x outside, by hoping that after you implement that method, you can simplify the form. So what is the technique that the most suitable here? Do you need to implement by parts? Maybe you can try by parts, or maybe you can use a substitution. So maybe, but not trigonometric identities, because normally we apply the trigonometric identities if there is a square root. There is square root in there, and of course not partial fraction, because nothing to do with a polynomial. Okay, so we can try these two technique. Okay, firstly, try the substitution. Okay, so how can the substitution works here? So in this case, because you want to substitute. Why we need the substitution? Because you want to rearrange this one into a simpler form, so that from there you can integrate easily. So that's the idea, the intention why you have to use the substitution. So you want to sub with a new expression, so that your original expression becomes more simpler. Okay, so then what is the thing that we can substitute for this? So it looks like you can substitute whatever in the bracket. So we hope that we can simplify after this. So we let so let's say I'm using u, so u equal to xy. So now your assumption here, there are x and y. So you want to differentiate with respect to y, you have du, dy or dy dx. So it depends on your order here. So your order here, there is dx. So meaning that from your assumption, you have to find the dx. So which means that how can you have dx? You have to differentiate du over dx. So du over dx. And you can see the dx here, right? Because you need the dx after this. You have to differentiate this with respect to x. So you will give y. Okay, 1x becomes 1. So now your dx becomes du over y. Okay, so then okay, I'll rewrite this here. So you have now x cos of xy dx. So by using the substitution, so x cos, and now u, and your dx now du over y. So you have x over y cos u du. So that is only for the inner integration here. Okay, so for you to use the substitution, meaning that you want to, in this case, you want to eliminate the x from the expression that you have. You want to eliminate the x. Okay, and this one becomes u, and x here and x here, so also becomes u. So as you can see here, so x, then this one becomes u, so your dx now du over y. So meaning that your x is still there. Okay, so you still cannot proceed to integration, because there is the x and the u still in there. So we actually, when you implement the substitution, you should eliminate the x. No more x, just u. And also y, because y can be done later, but not for x. You should have u here. So it looks like you have to replace. You still cannot integrate yet, but you have to replace the x in terms of u. So it looks like you can get it from here. So your x is equal to u over y. So you have u over y cos u du. Okay. So it looks like you have 1 over y, and then u cos u du. Then we can apply the by parts, because you have u cos u. Remember, there is a formula, not formula, there is a hint where and when you need to use the by parts technique. When there is a combination between a polynomial and the trigonometry, the exponential and the trigonometry, and I'm sure that you know that. But then for those who have forgotten, then you have to do some revision on the technique of integration. That is very important. Okay, so I will say that more than 50% of the content of this subject, they are related to integration. More than 50%. So if your integration technique is very, very weak, and I'm afraid that you have to take this subject again, and I'm afraid that you feel this subject is very, very tough. Okay, that is because of your mathematical background is not really good. So I understand some of you maybe is not really good in maths, but if you spend a lot of time or sometimes to do the revision, I'm sure that you can do it better. Okay, you can give me A, you can have A, you can get A for this subject, but you have to give a lot of effort. Okay. Okay, in this case now, maybe we can use the by parts, because at the moment 1 over y is a constant. Okay, now we just focus on the expression in terms of u, because we are actually we got u from x, right? Okay, so now by parts. So what by parts is? By parts, so what is the formula of by part? uv minus v du. Okay, so a bit confusing because now we are using u, right? So let's say I change that to be what? Vw. So dw and then dw. Okay, so now you have w, dw, w, 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 w. Okay, so for the by part itself, there is another way to simplify your work on finding or on using the by part, which we call the tabular method. So the tabular method is the generalization of the by parts technique. Okay, which means that I'm sure that your lecturers before this have already teach you how can we have the tabular method. So for the tabular method, you must have 2 columns, where the first column for differentiation. So you have the w cos w. Okay, so this one to be differentiate and this one to be integrate. So this is just 2 columns, and then you have to differentiate until you got 0, and then the integration part will follow through. So integrate sine cos minus sine w, negative cos w. Okay, so then your result, your integration of w cos w dw will give you negative w sine w. Yeah, this one plus minus, and then negative, so positive cos w. Okay, so then you have 1 over y, so your result there negative w sine w plus cos w. And then you have to put the limit, but your limit there belongs to x 0 to pi over 2. So in this case, this one is belongs to x0 to x equal to pi over 2. Right? But then because of now you have the expression in terms of w, but this one is belongs to x. So meaning that you have to find the value of w. This one. Okay. So you can just see that when x is 0, so your w is 0. When x is pi over 2, so your w is pi over 2y. So now your, so here negative w, sin w plus cos w. So our w from 0 to w equal to pi over 2y. Pi over 2y. So then we replace. So negative pi y over 2 sine pi y over 2 plus cos pi y over 2 minus negative 0 because w is 0, so 0 cos 0, so plus 1. Okay, so when we simplify, to have this one, this part becomes minus 1. So negative pi y over 2 sine pi y over 2 plus cos of pi y over 2. Okay, so now you can see that it's very complicated and you need very long steps here. And since it's very long steps, so it's easier for you to do some mistakes, right? Okay, just check whether, remember I did something wrong. So I replace w equal to xy, so dw dx is y, so dx is dw over y, and I put here, so x cos w dw over y, and then I have x over y, and because of we don't want x, we want w, so by using this one we have to replace x equal to w over y, w over y. Okay, salah. Okay, so I just realized we have I do some mistake there, which means that this one should be changed to be square. Okay, and there is a square here. So then we just want to integrate respect to w. So 1 over y squared is constant. So now we just focus on w cos w. So I'm using tabular method. So differentiate w till we get 0. W respect to w. So we got 1, 0. And integrate cos, you will get minus sine. And integrate sine, you got integrate. Okay, this is differentiate. So different. Okay. So integrate cos, I get sine. And integrate sine, I get negative cos. So then, so this one is supposed to be positive. And positive. Okay. So this one becomes square. and positive. Right. So this one positive. Okay. So just checking. So now we replaced W equal to, okay, the original limit is for x 0 to pi over 2. So now you cannot use x directly because your x now transformed into W. So using this relationship, so you have to have x equal to W. Okay, so your x here is W over y. So when x equal to 0, so W is 0. When x equal to pi over 2, so W is pi over 2y. Okay, now this is your new value of W that you have to put as your limit. This one. Okay, so now we substitute. So positive, W is pi y over 2, sine pi y over 2 plus cos pi y over 2, and then minus, and since W is 0, so this one 0, so positive 0, and this one cos 0. Apa? So then, okay, now I check. So there are a few things that I have to erase. So this is positive, sine plus, and then minus 1. Okay, so that is your result. Then using this result, okay, don't forget this one is y squared. Sorry. This one is y squared, and this one is y squared. And they are everything in terms of y, right? No more x. So then you have to substitute your result here. You have 1 over y squared, and then pi y over 2 multiplied by sine of pi y over 2, and then plus cos of pi y over 2 minus 1 dy. Okay, so next, you have 1 over y outside, and you have the sine inside, and similarly this one, then it looks like you have to implement another by parts. Okay, so for this case, I'm not going to finish this off. Maybe we can solve easily, or maybe it's something complicated. But okay, in this case, I don't want to proceed. Why? Okay, I show you. So not sure whether it can be solved or not. Okay, since it looks complicated, right? Why not? Okay, why not? We don't want to proceed with the dx dy. It looks like complicated, right? So now why not we choose another option, which is dy dx. So we hope that using dy dx, we will get the answer in more simpler way. Okay, so now we just leave this for a while. Okay, because I don't want to proceed this. It looks a bit complicated. So I just want to proceed with the second option, dy dx. Okay, now I proceed to second option, where I have the x cos of xy. So just now we choose dy dx. So I want to integrate respect to y first. So now the limit will follow through this information. So limit of x is 0 to pi over 2, and the limit of y is 0 to 1. So now I want to solve for the inner integration. Okay, so meaning that, okay, I just solve over here. So x cos xy dy. Okay, since now you want to solve the integrate respect to y, and your y is inside the cos, it looks like we in this case you don't need to use the by parts. By part is not help you, because by part is, you need by part if there is a combination between polynomial and the trigonometric function, or the exponential function with the trigonometric function, or maybe hyperbolic function. But in this case, your y is only inside the cos, so you don't need to use the by parts. So by part will not help you to solve this. So it looks like we can just use a substitution directly, which means that in this case we let, by using substitution, we let, I'm using u or w equal to xy, and since w now is in terms of xy, so you have to differentiate respect to x, or you have to differentiate respect to y. Which one? So now you see, now your order is dy, so meaning that you need the information about the dy. So how can you have the dy? Which means that from here you have to have dw over dy, so you will get x. So now you can get your dy is equal to dw over x. So now x cos w, and your dy is dw over x. So then the x here can be cancelled out. So now your new form of integrand in terms of w is more simpler. You just have cos w dw. So we can directly integrate cos. You will get sin w, and then you put the limit, but your limit is belongs to y, which is 0 to 1. But the variable that you have is w. So meaning that you have to find w for this specific y using this one. Okay. So when y is equal to 1, okay, when y is equal to 1, so w is equal to x. And when y equal to 0, so your w is equal to 0. So now your new interval is w equal to 0 to w equal to x. Okay, so when you solve that, so in this case, your w here is equal to x. So you will have sin x minus sin 0. So this one 0. And your answer is sin x. Remember, I told you before, your result of integration for the inner integration can be constant or can be an expression in terms of x or in terms of y. Depends on what kind of order of integration that you have. Okay, in this case, your first integration, which is your inner integration, is sin x. So now, just copy your final solution from your first integration. So you have sin x dx. So can we integrate sin x easily? Yes, of course. What is the integration of sin? Minus cos x. And the limit of x is from 0 to pi over 2. So we can have negative cos pi over 2 minus subtract with negative cos 0. Okay. So I don't have the calculator, but I'm using the graph of cos. So this is 2 pi, and this is pi, and this is pi over 2. So negative cos pi over 2, so minus 0 minus cos 0 is 1. So I will get 1. Okay, so the double integral of the x cos of xy, using this, we can solve easily. Okay, compared with if you use the dx dy, and you can see how can see it is. Maybe, yeah, of course you can solve, but it's not so direct, right? That's why I don't want to proceed, because I feel that if I'm using the dy dx, so I will get the answer more easy. Okay, I got so many questions from my previous class of this subject. The student were asking me, how can we know that this particular integrand cannot be solved by specific order of integration? So it depends on your, as I mentioned before, it depends on your understanding on how to integrate some functions. Because you can see that from this example, so you have the x cos xy and the x. So if you proceed with the x, so you, of course, you want to use the substitution, because we hope that by using substitution, the x outside here can be cancelled out. That is the idea of substitution, the nature of substitution, the intuition why we use the intention why we use the by the substitution is to simplify the form. So we hope that by using a substitution method, we can eliminate the x outside. How can you eliminate the x? So you should divide this by x, so that x and x cancel out. So how can you have the x down here divided by x? So you cannot have the x. You cannot something integrate to be with respect to x, otherwise you will get y. So that's why we want it to be to get the over x, then we must eliminate the y by integrating by using the substitution, which means that you have to use dy, so that your result here, when you substitute, you must have the dy here, right? So that you can only have x. So then after you apply the substitution, you will have the over x. So x and x can be cancelled out. So that is the process of the substitution. Okay, as I mentioned before, if you don't remember what is substitution mean, what is the byproduct mean, then you have to. So no one can help you. You have to help yourself to do some revision on that technique. Okay, so I'm sure that you okay with the differentiation, but you feel complicated. You feel very complicated about you feel the integration is very complicated thing. But again, if you just if you don't do some revision on it, so I don't think you can do very well for this chapter. And since at the end of the semester, there is one chapter, actually two chapters, which are the continuation of the multiple integrals. So as I mentioned before, the contents in this course, you will see the integration about 80% of this, the content of this subject. So please spend some time to do some revision on integration part. Okay.